So then we have the parallel, which is sending TIMBER all at once versus serially sending the T, the I, the M, the B, the E, the R. So hopefully we beat that to death and you understand that. And move data to and from random access memory and manage the flow of data to and from the networking cable. So we talked about getting data up into RAM through the DMA circuitry, the direct memory access, versus going through the CPU and having the CPU do it, which is slow. Relatively speaking, if you're trying to transfer a gigabyte of data from a drive into memory, you want to use a DMA. You don't want to go through the processor. That'll take much longer. And then we want to buffer the data from the computer. So buffering is just a placeholder for stuff like the printer, for example. If you want to buffer data on the computer, remember we talked about in the previous module, or the one before that even, we talked about printers a little bit. And we talked about that if you have a printer connected to your Windows XP computer and someone sends a job to it, it'll freeze your computer for a little bit of time while it's processing that job and getting it out there if it's graphic intensive. If it's just text, you may not notice it. It may just freeze for a second and then it'll print the job. But if it's a big graphic intensive job like a picture, say you're just going to print a picture of yourself, then your computer will freeze for a significant amount of time, or it may seem frozen to you. It'll become unresponsive, and while it's trying to print the job and doing all the translation, so it's chewing up your computer. So we want to buffer the data from the computer onto the printer. So I just send the job, and now I don't have to worry about it. It doesn't slow my computer down. The printers will have enough memory, that kind of thing. So that's what they're referring to here. You want to buffer the data from the computer, and the network cards will do that. So I just shove the data down to the network card. The network card is trying to communicate over to another network card saying, hey, did you get the T? Let's say we're sending Timber again. Say, did you get the T? Yes, I did. Okay, I'm gonna send the I. Are you ready? Yes, I'm ready. Here's the I. Okay, I got it. Or it might say, no, I didn't get it. No, I didn't get it. No, I didn't get it. So he's trying to retransmit it. Well, at the same time, I'm sending 1,000 more characters down the rest of this email or whatever it is I'm sending over this wire. The network card will buffer it. So they come with a lot of RAM and space to store this data and things like that, or ways to access it directly out of memory, like through a DMA channel, that kind of thing. So that's what we're talking about, buffering versus the actual chip having to send it as it's needed, because that's going to slow down everything else. If I can free up this chip and store the stuff in memory, and then the network card can access the memory, then now I can use this chip for other things. And that's how our computers are so fast today. Your computer can only do one thing at a time, right? Just one thing at a time. Your CPU can only do one thing at a time. It's literally going to process one thing at a time. But to you, you think you have 1,000 things going. You're playing music, you're sending out data over the network card, you're downloading movies, you're downloading all kinds of, not downloading movies because that would be illegal, but all kinds of other stuff, right? So you might be downloading important data files for work or school, right? So, but to you, it happens all at the same time because all of these circuits are working together, what I call the dance. They're all doing the dance. And then your computer, your CPU is processing things as it needs to, but it's using buffering strategies to say, hey, you do this for me, you do this for me. So it's more of a manager, although in this case it's a working manager, and it's saying you do this, you do that, you do this, I'll do this, here's this, I computed this for you, here you go. But it happens so fast to us, the efficiency and everything, usually, your computer's fast enough, and then they don't freeze, they do all this stuff at once. But really it's just doing one thing at a time, but you're getting time slices. So every program gets a time slice from the CPU. So this program gets about, say, a millisecond. It's not that long, but let's say that we chop it up into milliseconds as an example. So say I'm downloading and I'm printing a job. So we're gonna chop those up. So you get to print for a flash of a second, you get to download for a flash of a second, you get to print for a flash of a second. So to you, the user, those things are happening at the same time because it's fast enough to simulate real-time work. Okay, so that's kind of how these things work, and that's what the buffering is referring to. So buffering is done all over the computer system, not just on the network card, but they do it as well. Another thing they're talking about with the buffering is data coming in. So I might be receiving a file, but I'm not ready for it until I have the whole file, right? So that card will buffer the stuff into memory, and then when it's ready, it'll signal the CPU, and then the CPU will start pulling that data down or doing whatever it's going to do with it. Maybe it's storing it on the disk through another DMA channel, and it never even touched the CPU.